Hello there, and welcome to Science for Sleep, where curiosity floats gently into the quiet hours and science softens into story. Tonight, we're not chasing stars or unravelling time. We're doing something stranger. We're peering into what isn't there. We're diving into the spaces between things, into the hush, the gap, the emptiness. Or is it empty? You see, space, that vast black velvet stretched across the sky, looks so still, so silent, so still. But what if I told you that the void is humming with hidden dances, that nothing might not be nothing at all? Tonight's journey is about the nature of emptiness. We'll wander through the strange realm of vacuum energy, catch flickers of quantum whispers, and ask a few questions philosophers have been politely arguing over for centuries. But first, where are you listening from? And what does the night feel like where you are? Is it quiet or buzzing just beneath the surface? If this kind of wandering soothes your mind, if it gives your thoughts a soft place to land, I'd be so grateful if you gave this video a like, maybe even subscribed. It helps this sleepy little corner of the cosmos reach others who might need a peaceful pause too. But don't worry, this isn't the kind of mystery that demands staying awake. If you drift off halfway through, just know the nothingness will still be here, waiting. So settle in, slow your thoughts, and let's begin. Because in the heart of the void between atoms beneath silence, there might just be something hiding in the nothing. Nothingness isn't something we usually notice. It doesn't tap us on the shoulder or wave from across the room. It slips in between the things we do pay attention to. The pause between two sentences, the quiet after the lights go out. That strange moment before a thought arrives, or just after one leaves, and yet we feel it. Think of a silent room, no hum of a fridge, no voices, not even the wind, just a thick, velvety quiet. At first it's peaceful, but after a while, your mind starts to itch. Something in you wants to fill that silence. With a word, a hum, a flick of your phone screen. That's the funny thing about nothing. It's heavy. Not in mass, but in meaning. We're not very good at leaving things empty. We fill notebooks with doodles and margins with daydreams. We name the stars even when they're just pixels in the dark. We talk through awkward silences, even if we have nothing to say. We're builders, storers, thinkers, hoarders of noise and narrative. But every so often, when we lie awake at night staring at the ceiling, or when we walk alone under a sky too wide to understand, we feel it. The vastness, the space, the presence of absence. And it's not just outside us. There's a kind of inner emptiness too, not sadness, just stillness. A hollow between the moments where we're not actively thinking, not remembering, not planning, just existing. Like an open window on a windless night. What is that? Where are we in that moment? Is it rest? Or is it something more? Some subtle conversation between our consciousness and the invisible backdrop of reality? We tend to imagine the world as a collection of things. Chairs, trees, planets, particles. But what about the spaces in between? The emptiness that cradles everything else? We rarely ask, what is the stage the universe is set upon? Imagine walking into an empty theatre. No actors, no set, just a spotlight on a bare floor. Most people would say, there's nothing here. But even in that nothing, you're still somewhere. There's space, and that space has rules. It has shape. It can echo. And if you sit quietly enough, you might hear something beneath the silence. The possibility of something happening. That's what this journey's about the strange truth that what we call empty space might be buzzing, trembling, alive in ways we're only beginning to understand. You've felt this before, haven't you? That odd moment when you turn off the TV and the silence feels too loud. Or when you're hiking alone far from any town and the air feels thick with something you can't name. Not fear exactly, not wonder, just a sense that the emptiness, isn't entirely empty. We feel these spaces. They unsettle us a little, because we expect the world to be made of things. But here is the world, whispering between those things. Here is the vacuum, soft and invisible, with secrets curled into its quiet. In fact, some scientists argue that the nothing of space is more like a storm beneath still water, a place where particles flicker in and out of existence, where energy hides in plain sight, where the void isn't void at all. But we're getting ahead of ourselves. For now, just stay with this feeling, this soft mystery. Not a question to solve, but a presence to observe, like the feeling of a room you thought was empty, until you noticed it watching you back. Long before anyone spoke of particles or quantum foam, before vacuums were defined by pressure or absence, people still looked out at the night sky and felt the space between stars. That feeling, that tug from the dark, it's ancient, older than cities, older, even, than stories. In the beginning, nearly every culture had a myth about what existed before existence, a kind of cosmic prelude, a blank page before the poem. To the Maori there was Takore, the great void, not empty, but full of potential, a nothingness that wasn't absence but the pregnant hush before the world was born. In Hindu cosmology, there's shunyata, the concept of emptiness, not a lack, but a fullness beyond form, emptiness as the canvas of being. It's not the end of things, but their quiet foundation. Even the ancient Egyptians spoke of the primordial waters, none, a boundless dark sea that existed before the gods, a place of chaos and mystery, but also of creation. Because from nothing they believed everything arose. Over in Greece, the philosopher Parmenides declared, with some certainty, that nothing could not exist. To speak of it was already to give it substance. If you could name the void, then it wasn't truly void at all. But not everyone agreed. His student Democritus, one of the earliest atomic theorists, proposed that the universe was made of tiny, indivisible atoms floating in, what else? Empty space. The void. He called it Kenon, a vast silent backdrop through which atoms danced and collided. To him, the void was as real as the particles that moved within it, and so the debate began, a gentle tug-of-war between emptiness and being, between the seen and the space between. In Chinese Taoist philosophy, this tension was not something to solve, but something to embrace. The Tao Te Ching speaks often of the value of emptiness. 30 spokes share the wheel's hub. It is the center hole that makes it useful. The cup is only useful because of the empty space inside. It's not the wall that defines the room, but the space it encloses. They saw emptiness not as something missing, but as the quiet heart of usefulness. And maybe that's something we've always known, deep in the softest part of ourselves. The pause in a piece of music can be more moving than the notes. The breath between words can say more than the words themselves. Even in Abrahamic traditions, the creation story begins with void. In the beginning, Genesis tells us, the earth was formless and empty, and darkness was over the surface of the deep. The act of creation is an act of dividing emptiness, light from dark, water from sky, land from sea. It's not that the void was nothing, it's that the void was first, and always. We've tried to understand it. The early Islamic philosophers argued whether the vacuum could exist at all. Many believed that true emptiness was impossible, that God's presence must fill every space, and in medieval Europe the prevailing wisdom was summed up in a Latin phrase, natura abhorret a vacuo. Nature abhors a vacuum. It was widely believed that the universe wouldn't allow empty space to exist. If something tried to leave a space unfilled, something else would rush in to take its place, and so they built bell jars and water pumps and tried to prove, again and again, whether emptiness could be real. Each time they thought they'd caught it, emptiness slipped through their fingers or hissed quietly back in. Of course, part of this wasn't science. It was fear. The idea of true nothingness was unsettling. It still is. We're creatures of pattern and purpose. We like our stories to have beginnings, middles and ends. We like our maps filled in, even if it's with dragons and dotted lines. Nothing is hard to draw, hard to narrate, hard to feel comfortable with, and yet we keep circling it. In Japanese Zen Buddhism, there's the concept of mu, a kind of non-being, a gentle unasking of the question. If someone asks, "Does a dog have Buddha nature?" the master replies, "Mu," not yes, not no, just emptiness. An invitation to stop trying to define, to stop trying to fill. Because sometimes the answer is the space between questions, and all across the world our languages reflect this quiet curiosity. In English we say empty as if it's a defect, a glass that should be full. But in Sanskrit, shunya carries a different tone. It's used in mathematics to mean zero, but also in spirituality to mean serene detachment. In Hebrew, tohu vabohu describes a formless void, but not in fear, in readiness. In the Inuit language, there are words for different kinds of silence. Silence that listens, silence that waits, silence that speaks. Perhaps that's the lesson, that emptiness has tones, that nothing is not uniform, that even the vacuum can whisper. And so, across centuries through ritual and rhyme, humans have tiptoed around the mystery of nothing. They've painted it in myth, etched it in stone, sung it in poems, and stared into it on cold, clear nights. And though the words may differ, a quiet consensus forms that emptiness is never truly empty, that what we don't see might still be there, tucked just behind perception. Not void, but veil. Not lack, but layer. A hidden fullness disguised as stillness. If you had a perfect box sealed on all sides and you carefully removed every grain of dust, every molecule of air, every drop of light and heat and sound, would you have a box full of nothing? At one time, scientists would have said yes. That's a vacuum, a pure, clean emptiness, a space where nothing exists, nothing to move, nothing to feel, nothing to be. But physics, as it often does, had a few surprises up its sleeve. Because it turns out space is never truly empty. Not even in the loneliest stretches between stars, not even in the vast, dark silence between galaxies. Even when you remove everything you can, strip it down to the bones of reality, something remains, the vacuum itself. But let's not rush. Let's begin with what a vacuum used to mean. In classical physics, think Newton and his apples. A vacuum was just the absence of matter. No particles, no atoms. A useful concept, especially when studying things like falling objects or the soundless emptiness of outer space. Vacuum chambers were built in labs, glass domes pumped of air, where feathers and hammers could fall together, proving that in the absence of resistance, gravity treats all things equally. It was elegant, predictable, comfortably empty. But as scientists peered closer into the fabric of the universe, zooming beyond the scales of apples and feathers and vacuum pumps, something strange began to appear. Even in total darkness at temperatures near absolute zero with all known matter removed, the emptiness wiggled, it shimmered, it flickered. It wasn't still. This was not the clean emptiness of Newton. This was something new, something quantum, at the tiniest scales, far smaller than atoms or even protons. The universe begins to behave like a wild improvisational dance. Particles and waves blur into each other. Probability replaces certainty, and the vacuum, instead of being empty, turns out to be full of possibilities. Enter quantum fluctuations. These are tiny, momentary changes in the amount of energy in a point of space. They happen constantly, everywhere, even in perfect vacuum. Particles and antiparticles flicker into existence, pair off like brief lovers at a cosmic ball, then annihilate each other just as quickly, vanishing back into the backdrop. It's as if the universe cannot bear to sit still, not even for a heartbeat. These fluctuations are not just metaphorical, they're measurable. They have effects. In fact, the reason your computer works, the reason atoms don't collapse, the reason the stars shine, they all depend in some way on this restless, trembling vacuum. And while this might sound chaotic, there's an order to the madness. These fluctuations are governed by a deep, mysterious rule, the Heisenberg uncertainty principle. It says, in essence, that you can't know everything about a particle at once. You can measure where it is or how fast it's moving, but not both, not precisely, not at the same time. This limit creates room for fluctuations, a kind of cosmic wiggle room built into the equations of reality. And so, even in a vacuum, there's always something happening. Not in the usual sense, no movement, no heat, but a buzz of virtual particles, a storm of maybe and might. Physicists call this invisible energy the zero-point energy. It's the lowest possible energy a system can have. Even when all else is removed, this remains, a sort of bass hum of the universe. If space were a violin string, zero-point energy would be the note it plays even when no one is touching it. But here's where things get stranger still. This background hum, this gentle trembling of the vacuum, isn't just a curiosity. It might be the scaffolding of everything we know. There's a theory, called quantum field theory, that says what we think of as particles aren't really standalone things. They're just little ripples in underlying fields that stretch across the universe. Electrons are ripples in the electron field, photons in the electromagnetic field, quarks in their own peculiar fields, and even when there are no ripples, no particles, no waves, those fields still exist, still shiver, still breathe. So when we say vacuum, what we really mean is the lowest energy state of a quantum field. Not nothing, just the calmest possible version of something. Imagine the surface of a pond. If it's flat, you might think it's still. But if you could look close enough, really close, you'd see it vibrating, microscopic waves dancing across it. Now imagine that pond stretches endlessly in every direction and underpins every particle in existence. That's what the vacuum is. Not a container for the universe, but the universe itself at its quietest. And yet, even this quiet isn't fully still, because in certain circumstances, this vacuum energy can do things. It can push, it can pull, it can affect the real, measurable world in ways that scientists can observe and predict. There's even a strange phenomenon called the Casimir effect, where two uncharged metal plates, placed extremely close together in a vacuum, will attract each other. Why? Because the quantum vacuum fluctuations between the plates are slightly different than those outside. The vacuum has pressure, the vacuum has mood, it's like space is whispering closer, and the plates obey. This isn't science fiction. It's been tested, measured, repeated. The vacuum isn't passive, it's an active player in the cosmos, and some theories go further, suggesting that this vacuum energy might be linked to one of the greatest mysteries in all of physics, dark energy. That strange, invisible force causing the universe to expand faster and faster, as if space itself were stretching, yearning, accelerating towards some unseen edge. Some physicists believe dark energy is the result of vacuum energy on a cosmic scale. The empty parts of space aren't just neutral, they're pushing everything apart. Not because of stars, not because of gravity, but because of the nature of nothing itself. So what are we to make of this? That empty space is never truly empty. That every vacuum is full of fields and fluctuations. That the nothing between things might be the most something part of all. It's a strange thought, isn't it? That silence could sing, that stillness could shimmer, that the very fabric of space might ripple with invisible tides. And if we take this seriously, if the vacuum is not absence but presence, then everything we think of as solid, every star, every thought, every breath is floating on something we once thought was nothing. So we've wandered into the vacuum, this strange shimmering backdrop of reality, and found it humming quietly to itself, full of restless fluctuations of borrowed particles flickering in and out of being. But that's not the end of the story, not even close, because the vacuum, as it turns out, might not be just energetic, it might be complicated. To understand this, we need to talk about something called the vacuum state. In quantum field theory, the vacuum is not a single thing, not one universal floor that everything sits on. It's a landscape of possible vacua, plural. Some are higher in energy, some are lower, some are stable, some are not. And that brings us to an eerie idea. What if the vacuum we live in isn't the lowest possible vacuum? What if it's just a temporary valley in a much bigger mountain range? This idea is called the false vacuum hypothesis, and it's unsettling. Imagine rolling a ball across a hilly landscape. It settles in a dip. It seems stable. But further away there's a deeper valley, one that the ball doesn't know about. It's stuck in a local minimum. It thinks it's found its rest, but it's only found a pause. That's what our universe might be. A pause, a temporary equilibrium. And if that's true, it means that our vacuum, the nothing we live in, is not truly stable. It could decay, not into fire or explosion, but into a new kind of vacuum, one with different laws of physics, where light might not behave the same, where electrons may not exist, where life, as we know it, would be instantly erased. This vacuum decay would spread at the speed of light, a bubble of true vacuum expanding through the old, and we'd never see it coming. But don't worry, if it ever happens, you won't notice. The laws of time and thought and matter will dissolve in an instant. There would be no pain, no awareness, just a sudden rearrangement of reality. It sounds like science fiction, but this is a real theory taken seriously by physicists. Some models of particle physics, especially those involving the Higgs field, suggest that we might, just might, be living in a metastable vacuum, a false vacuum, balanced, but precarious. But here's the comforting twist. If it hasn't happened yet, it may never happen at all. Quantum tunneling, the mechanism by which the vacuum might decay, is unpredictable. It could take billions of times longer than the age of the universe, or not happen ever. A loaded die that never rolls. Still, it's a strange thing, isn't it? To live inside a kind of nothing that might not be done becoming something, and stranger still, this vacuum we call empty might be where everything began. Let's rewind. Back to before stars, before time, before space even, before the universe existed. Was there a vacuum? In the standard model of cosmology, the Big Bang is not an explosion in space. It's the birth of space itself. And some versions of this theory suggest that our universe began as a quantum fluctuation in a pre-existing vacuum. Yes, from nothing. Everything. Not a nothing you can hold, not an emptiness like a jar, but a quantum nothing. A restless sea of potential in which fluctuations can happen even without space or time. These ideas are part of a field called quantum cosmology, where physicists attempt to describe how the universe could arise from a vacuum. And in some models, particularly those involving inflation, the vacuum energy played a starring role. Shortly after the Big Bang, they say, there was a moment of exponential expansion. Space didn't just grow, it ballooned, faster than the speed of light, not matter, not signals, just space itself. And what powered this explosion? The vacuum, specifically a high-energy vacuum state that suddenly decayed into a lower state, releasing an immense flood of energy. The heat and matter that would become galaxies, stars, planets. You. This idea is called inflation theory, and while it's still evolving, it's supported by many observations. The uniformity of the cosmic microwave background, the large-scale structure of the universe, the flatness of space. And if it's true, it means the vacuum is not just the backdrop of reality, but the womb from which reality was born. Now take a breath, because it gets weirder. Some theories of inflation suggest it never fully stops, that in some distant regions of the vacuum, inflation continues endlessly, budding off new universes like soap bubbles, each one with its own vacuum, its own laws, its own story. This is called eternal inflation, and it leads to a bold idea, the multiverse, a vast landscape of universes, each born from quantum fluctuations, each unfolding within its own vacuum. And what separates these worlds? Empty space, the vacuum again, not as absence, but as the connective tissue between realities, the silence between songs, the canvas on which infinity is painted. You may be wondering, how can something so still give rise to so much? How can nothing do anything? But maybe we've misunderstood it. Maybe nothing was never nothing at all. Maybe it was potential, quietly waiting for a reason. In theoretical physics, there are models that explore this explicitly, that describe the vacuum not just as absence, but as a quantum potentiality, a field of infinite possible configurations where the right fluctuation can spin reality into being. And in these models, everything, from the shape of space to the charge of an electron to the ticking of your heart, can trace its lineage back to a whisper in the vacuum. But let's pull back. Not all vacua are grand or cosmic. Even inside atoms, even between the nuclei and the electron shells, there is vacuum. Tiny fields stretching inside you right now, in your body, your brain, your breath. In fact, most of what you are is vacuum. If you removed all the space between the atoms in your body, you'd be no larger than a grain of salt. So where are you? Are you the matter, or the space between? Are you something, or the shimmer of something inside nothing? That's what the vacuum teaches us, that boundaries blur, that emptiness might be the source, that even stillness hums, and that the quietest parts of the universe may be the most alive. Let's return to that quiet, invisible field, the vacuum, not as an absence, but as an entity, a mechanism, a system, a softly buzzing stage beneath the play of everything. It may seem strange to call nothingness a system, but in quantum physics, that's precisely how it's seen. Everywhere in space, even in the coldest regions far from starlight or planets or breath, fields stretch out invisibly, quietly. They're not made of particles exactly. Instead, particles are what we call little ripples in the fields, local vibrations like wind on water. In this picture of the universe, what we call empty space is the resting state of these fields. It's what the universe looks like when nothing in particular is happening. But even then, something is always happening. Remember, at the quantum scale, uncertainty reigns. The vacuum is never flat. It jitters, it twitches. It allows the brief birth and disappearance of what physicists call virtual particles. These aren't particles like the ones in your breakfast cereal. They're temporary fluctuations, pairs of energy and anti-energy that bubble into reality, interact ever so slightly, and then vanish again, like breath fog on a window. They don't last long enough to be seen directly, but their effects can be measured, and in some experiments, they have been. One of the most striking is the Lamb shift, a tiny change in the energy level of an electron orbiting inside a hydrogen atom. Classical physics says it should be here, but it's a little bit there. Why? Because the vacuum beneath that electron isn't still. The fluctuations nudge it, jostle it, ever so slightly. It's as if space itself is breathing beneath the electron, whispering soft corrections to its behavior. Another experiment, the Casimir effect, which we visited briefly before. Two tiny metal plates placed close together in a vacuum start to attract each other, not because of gravity, not because of magnetism, but because of the quantum fields between them and around them. The vacuum outside the plates has more energy than the vacuum inside, and so the plates are pushed together by nothing, or rather, by the imbalance of invisible somethings within the nothing. This is not imagination, it's measurable, predictable, and real. These effects confirm what quantum theory has long said, that the vacuum is alive with activity. A sea of subtle vibrations, always trembling at the edge of visibility, and that trembling matters. It affects atoms, particles, and even the expansion of the universe. The vacuum isn't just a curiosity for particle physicists or a playground for lab experiments. It touches the whole structure of the cosmos. Its energy, called the vacuum energy, or sometimes the cosmological constant, acts as a kind of pressure on the fabric of space itself. Einstein first introduced the cosmological constant as a mathematical fix. He believed the universe was static, unchanging, and so he added this term to counteract gravity in his equations. Later, when Hubble observed that galaxies were flying apart, Einstein called his constant his greatest blunder. But then, decades later, scientists noticed something strange. Not only was the universe expanding, it was accelerating, as if some invisible force was stretching space faster and faster. And suddenly, Einstein's blunder was looking a lot like foresight. Today we believe that vacuum energy might be the source of this mysterious dark energy that powers cosmic acceleration. Not dark in colour, dark in understanding. It doesn't glow, it doesn't clump, but it's there, stretching the void, making more of nothing every second. Imagine that. A universe expanding not because of stars, but because the space between stars is gently pushing itself apart. We don't know how it works. We barely know that it works. But observations of distant supernova, of the cosmic microwave background, of the clustering of galaxies, they all whisper the same story. Space isn't idle, it stretches, and the vacuum is the reason. Some theories even propose that this vacuum energy is a property not of matter but of space itself, that for every cubic centimetre of space, no matter how empty, there is a tiny bit of energy humming within it. And if you multiply that by the size of the universe, you get a lot. A ridiculous amount, in fact. But here's the twist. When physicists try to calculate how much energy the vacuum should contain, according to quantum field theory, they get a number that's 120 orders of magnitude too big. That's a 1 followed by 120 zeros. This mismatch between theory and observation is one of the biggest unsolved problems in physics. We call it the vacuum catastrophe. And despite decades of thinking, we still don't know why. Some believe it points to new physics, others think we're missing something fundamental about reality. But whatever the answer, one thing is clear. We don't fully understand nothing, and maybe we never will. Let's drift now to the edge of science, the places where theory starts to warp and space itself becomes unstable. Black holes, cosmic strings, vacuum decay. In these places the vacuum acts strangely. Near the event horizon of a black hole, for example, quantum fields become distorted. Gravity bends not only light, but space and vacuum itself. And in this extreme region, something called Hawking radiation can occur. Stephen Hawking proposed that black holes aren't entirely black, that they emit a faint radiation caused by quantum fluctuations at the event horizon. Virtual particle pairs form. One falls in, one escapes. And the result? The black hole slowly loses mass. It evaporates, fades, and eventually disappears, all because of the vacuum. Not the stars, not the stuff, but the shimmer beneath them. It's haunting, isn't it? That a hole in space can die of loneliness. And then there's vacuum decay, the possibility we touched on before, that our vacuum isn't the true one, that somewhere in the landscape of energy there's a lower state waiting to be discovered, and if the vacuum ever decays, the laws of physics may change. Fundamental constants may shift. The fabric of existence could be rewritten. It would be silent, instant, total. But again, don't worry. Even the most doomsaying physicists agree it probably won't happen, and even if it does, you'll never know. Still, it's a remarkable thought. that reality itself might be a temporary arrangement, a song in the middle of being sung, and that beneath it all, the vacuum is listening. By now, the vacuum no longer feels like an absence. It feels more like a presence, a participant in reality, invisible, subtle, but deeply involved. Still, we're not done. There are more strange corners to explore, more experiments to unearth, more questions to ask in the soft hush between the known and the unknowable. Let's begin with an idea called vacuum polarization. This happens when an electric field disturbs the vacuum, pulls at it, you might say. In quantum electrodynamics, when a charged particle like an electron enters a vacuum, it's not just sitting in space, it's disturbing it, warping the quantum fields all around. You can imagine it like a drop falling into a still pond. Ripples spread. But these aren't water ripples. They're fluctuations, virtual particles spontaneously aligning themselves around the real one. The vacuum in this view acts almost like a lens, changing how forces behave at extremely small distances. This vacuum response is not poetic metaphor. It has measurable effects. It changes the observed charge of particles. It alters how they interact. What we call an electron in the lab is actually the core particle, plus the storm of virtual particles it stirs up in the vacuum around it. So when you look at matter, you're not just seeing matter, you're seeing matter dressed in vacuum fluctuations, an invisible cloak of borrowed existence. And this leads to even wilder frontiers. In particle accelerators, those vast machines that hurl protons into each other at nearly the speed of light, we've learned to probe the vacuum by shaking it violently. When energies get high enough, the vacuum itself can break, spawning real particles from virtual ones. This is known as pair production, and it's one of the closest things we have to creating something from nothing. High-energy photons can, in the right conditions, transform into an electron and a positron, a matter-antimatter pair, popped from the field into actual observable being. It's as if the vacuum were a tightly coiled spring. Add enough energy, and it uncoils into form, and that's not even the limit. There's a theoretical boundary, a terrifyingly beautiful one, called the Schwinger limit, named after Julian Schwinger, one of the founders of quantum electrodynamics. This limit describes the strength of an electric field so intense that it can rip virtual particles out of the vacuum continuously, creating cascades of real particles from the void. We haven't reached this limit yet, but we're getting closer with the rise of next-generation lasers that can deliver unimaginable energy into unimaginably small spaces. If we ever cross that threshold, we won't just be observing the vacuum, we'll be sculpting it. That's a strange kind of power, isn't it? To reshape nothing into something by sheer force of understanding, but the vacuum still resists full comprehension. It has moods we don't yet know how to name. Let's talk about symmetry breaking. In physics, symmetry is not just beauty, it's a principle. It means that the laws of physics don't care where you are or when or how fast you're moving. They apply equally everywhere, or at least they did. In the early universe, just after the Big Bang, it's believed that all the fundamental forces, gravity, electromagnetism, the nuclear forces, were unified. A single, elegant force. No divisions, perfect symmetry. But as the universe expanded and cooled, that symmetry broke, and each force took on its own identity, its own properties, like a glass pane cracking into 4 distinct shards. This breaking of symmetry was not just a change in the forces, it was a shift in the vacuum itself. Physicists call it a vacuum phase transition. In that moment, the vacuum changed its shape, its energy, its rules, and in doing so, it created the scaffolding on which all matter is built. This is not unlike what happens when water freezes into ice. It goes from a fluid, symmetric state to a solid, structured one, and suddenly, new properties emerge. Crystals, angles, edges. The vacuum, too, can freeze, can shift. And that's why scientists continue to look closely at it. Not just as the stage, but as a player in the unfolding of everything. We're still finding new ways to probe it. In some experiments, scientists use Bose-Einstein condensates, ultra-cold clouds of atoms slowed to nearly absolute zero, where the boundaries between particles blur and the vacuum-like nature of matter becomes more apparent. Other researchers work with vacuum birefringence, an effect where light, travelling through a vacuum in the presence of a strong magnetic field, is subtly altered, its polarization rotated as if the vacuum were a kind of prism. This was once pure theory, but today, experiments at facilities like CERN and other high-energy labs are beginning to nudge the vacuum into revealing more, and still it holds back, keeps secrets. Let's now enter a stranger domain, the vacuum and the holographic principle. Some physicists believe that space itself, the three-dimensional reality we know, might be a projection, that we live on the surface of a deeper information structure, a cosmic hologram. This idea, known as the holographic principle, suggests that the information of all we see might be stored on a distant boundary, and that what we experience as space and vacuum and form is simply a kind of emergent illusion. In this model, the vacuum isn't just energetic, it's encoded. Every point of space contains not just jittering particles, but information, patterns of bits and probabilities that define how reality behaves. It's like a soft whisper of a deeper language, written on the walls of the universe. We don't know yet if this is true, but it's part of a growing effort to understand not just what the vacuum does, but what it means. And maybe meaning is the last frontier of this topic. Because the vacuum, for all its energy, still feels like a mystery, still evokes something beyond physics. We think of it in metaphors. The still pond, the ocean of potential, the cosmic breath. We build experiments, launch satellites, cool atoms to a fraction above nothing, trying to catch it in the act. But it remains soft-spoken. We reach toward it, this quiet fullness, this trembling stillness, and it does not resist. But it doesn't quite surrender either. It simply is, and maybe that's enough. Long before we had equations, before particle colliders or vacuum pumps or lasers pulsing in silence, we had only our senses. And the space between things, the gaps, the pauses, the quiet, was unknowable. To the earliest humans, the void was not just absence, it was danger. A dark corner could hide a predator, an empty field could mean no food, an unanswered silence might mean a storm is coming. Emptiness was feared, not because it was quiet, but because it was out of reach. And yet, the fear was not without fascination. The ancient Greeks, always fond of paradoxes, wrestled with the idea of the vacuum. Aristotle, perhaps the loudest voice of his age, famously declared that nature abhors a vacuum. In his view, the world was made of four elements: earth, water, air, fire, and between them, no empty space could exist. Everything touched something else. There was no room for nothing. It wasn't just metaphysical, it was moral. Emptiness, in a way, was chaos. To suggest that something could exist in nothing was to challenge the very structure of how things were supposed to work. So for nearly 2,000 years, the vacuum was taboo, but not to everyone. The Greek atomists, Democritus and Leucippus, dared to imagine otherwise. They proposed that everything was made of tiny, indivisible units, atoms, and that these atoms moved freely through empty space. The vacuum, they argued, was not only real, it was necessary. Without emptiness, atoms could not move. Without space between things, nothing could change. They saw the void not as absence, but as the condition for motion, the background of becoming. But their voices were quiet ones, lost in time, overshadowed by more respectable theories. It wasn't until the 17th century, in the age of experiment and glass and gearwork, that the vacuum returned. Evangelista Torricelli, an Italian physicist, conducted a simple but stunning experiment. He filled a long glass tube with mercury, inverted it into a dish, and watched as the mercury settled, leaving a small empty space at the top of the tube. He had created a vacuum. It was the first time, perhaps in history, that humans had seen emptiness. Not imagined it, not feared it, but observed it. Shortly after, Otto von Guericke, a German scientist and mayor, built the first vacuum pump, a machine that could remove air from a sealed container. To prove its power, he held a public demonstration. He took 2 metal hemispheres, sealed them together, pumped out the air inside, and challenged teams of horses to pull them apart. They couldn't. It wasn't the metal or the glue holding them together. It was the pressure of the outside world pressing inward against a space that had been emptied. The vacuum, it seemed, had weight, a nothing with strength. And suddenly, the idea of a vacuum became very real. In France, Blaise Pascal continued the experiments, carrying barometers up mountains to show that air pressure and the vacuum it pushed against varied with height. In England, Robert Boyle refined vacuum pumps, studying how sound, combustion, and even small animals behaved in evacuated chambers. He noted that candles wouldn't burn, bells wouldn't ring, mice wouldn't live. It wasn't magic. It was the absence of something, air, which until then had been too invisible to consider. The vacuum had taught us what wasn't there, and in doing so revealed what was. From these early experiments, a new science was born, the science of pressure, gas, and space. Then came Newton. Sir Isaac Newton didn't fear the vacuum, he embraced it. In his mechanics, objects moved in straight lines through space, and that space could be empty. For Newton, the vacuum was not only real, it was essential. Space, he believed, was an infinite container, and time ticked evenly across it, whether or not anything happened inside. He called it absolute space. And the vacuum was its clean, blank face. But not everyone agreed. His rival, Gottfried Wilhelm Leibniz, insisted that space had no meaning without objects, that emptiness was not a thing, but a relation, a way of talking about how things stood apart. The debate simmered, and then, much later, Einstein changed the game entirely. In 1905 and again in 1915, Einstein published his theories of relativity, and in doing so he shattered the Newtonian idea of passive empty space. According to relativity, space and time were not separate. They were one fabric, space-time, and that fabric could bend, warp, stretch or compress depending on the matter and energy within it. The vacuum was no longer a stage. It was part of the play, and just as a trampoline sags beneath weight, so too does the vacuum curve in the presence of mass. This explained gravity in a whole new way. It also opened the door to something stranger. If the vacuum could bend, could it ripple? Could it vibrate? In the decades that followed, scientists explored the quantum world, a world where particles behaved like waves and uncertainty ruled. It was here that the vacuum was reborn yet again, not as empty space, but as a quantum field, a sea of potential, a fluctuating surface, a place where particles could be summoned by energy alone. In 1948, physicist Hendrik Casimir predicted that 2 uncharged plates placed closely in a vacuum would be drawn together, not by gravity, but by the absence of virtual particles between them. He had discovered the Casimir effect, and once again, experiments proved him right. Nothing was pulling, or more precisely, not nothing. The quantum vacuum had pressure, texture, presence. Then came quantum electrodynamics, quantum chromodynamics, the standard model of particle physics, each adding complexity to our understanding of what empty space truly meant. The discovery of the Higgs field in 2012 was another turning point. Here was a field present in every point of space, responsible for giving particles their mass. It wasn't that particles travelled through nothing, they travelled through something, a field, a vacuum with rules. And now, as cosmologists look to the stars, they speak of vacuum energy as the force behind the accelerating universe, of inflation, a brief moment in the early universe when vacuum energy caused space to grow faster than light, and of dark energy, a term still wrapped in mystery, which might simply be the weight of nothing on everything. Today, the vacuum is not feared, but it is revered. We no longer call it empty. We call it dynamic, structured, alive with possibilities, and yet it still holds its secrets. Some scientists believe our vacuum isn't the final one, that it might decay into a more stable state. That reality as we know it is balanced on a temporary plateau. Others explore the idea of multiple vacua, a landscape of energy states, each giving rise to different universes, with different particles, different physics, different stories. And so, the vacuum has gone from myth to metaphor to measurement to mystery again. Like a wave returning to the sea, it is not the absence of all things, it is the presence of all potential, a whisper that became a word that became a world. There are questions we carry not because we need the answers, but because we want the company. They sit with us at night, those soft impossibles, nudging at our awareness as we lie in bed staring into the ceiling's quiet. What is nothing? Where does being begin? Why is there something here instead of silence? We ask these not out of panic, but out of awe. It's the kind of awe that doesn't shout. It whispers, like wind through the trees, like memory, like the pause between two thoughts. The idea of nothing is older than any civilization, but it never grows tired. Philosophers, scientists, mystics, they've all reached toward it, as if touching the edge of a veil. In ancient India, the Upanishads spoke of shunyata, emptiness, not as loss but as clarity, a state in which self and world dissolve into the same open space. In early Taoism, Laozi tells us, we shape clay into a pot, but it is the emptiness inside that holds. The room is useful because of its open space, and long before physics had particles and fields and quantum foam, these traditions were already listening to the quiet hum beneath things. Today, our science meets their silence. Because when modern physics tries to answer where the universe came from, it circles back to a strange kind of vacuum. A vacuum not defined by absence, but by potential. A quantum nothingness in which fluctuations never stop and virtual particles blink in and out of existence, like stars that never stay. This isn't just a poetic gesture, it's the mathematics of the real. In quantum field theory, the vacuum is the lowest energy state of a system, but even that isn't perfectly still. There are waves beneath the silence, tensions under the calm. Particles can be pulled from the vacuum under the right conditions. The Casimir effect, the Unruh effect, even Hawking radiation at the edge of a black hole. They all suggest that emptiness is full of motion. And so we wonder, is this the root of existence? Is this how universes begin? From a false vacuum, unstable but full of tension, one bubble forms, inflates, expands, and inside it particles, forces, time, you. Some call this cosmic inflation, a scientific theory, but also a philosophical story, a creation tale told in wavelengths and metrics instead of fire and gods. But even if it's true, it doesn't solve the puzzle, because then we ask, where did the vacuum come from? What breathed into that space the rules of fluctuation? What wrote the laws that allow randomness to birth reality? Even if something arises from nothing, the laws that allow it to arise are still something. So we circle back, not to answer, but to stand still in the presence of a deeper mystery, one that doesn't ask for solutions, only attention. Some physicists suggest that the laws of nature are not absolute, that perhaps they too emerge from fluctuations, that what we see as the vacuum is just one region in a vast landscape of possibilities, and in that landscape different laws may hold sway, different constants, different concepts of space, time, energy. You might call that the multiverse, or the eternal inflation model, or the string theory landscape. But under every name, the question remains the same. How can there be anything at all? We're not the first to wonder this. In the 20th century, philosopher Martin Heidegger called it the fundamental question of metaphysics. Why is there something rather than nothing? He never found an answer, but he believed that by asking we meet the world differently, more honestly, more deeply, more like children watching snowfall without trying to catch it. What if the nothing we fear is not lack, but origin, not a threat, but mirror? We often think of being as primary. We're here, we act, we build. And absence is what's left behind when something breaks or ends. But what if it's the other way around? What if non-being is the constant, the canvas, and being is the rare splash of colour? In that light, emptiness becomes sacred. Not because it holds nothing, but because it holds everything. In potential, in balance, in rest. Even in psychology, there are moments of this: meditation, dreamlessness, stillness, when the mind falls quiet and thought slows down until it dissolves. In those moments, we don't vanish, we return. We re-enter some shared field of presence that doesn't need names or boundaries. It feels like space, but it also feels like home. And maybe that's what the vacuum is, not a cold absence, but a ground, a hum beneath all doing. In mysticism, this is the cloud of unknowing, the pregnant void, the womb of the world. Even the Kabbalistic creation story begins not with light, but with Tzimtzum, a divine withdrawal, an act in which the infinite retreats, creating space for the finite to exist. A vacuum, so that something else can arrive. In this story, God does not impose being. He makes room for it. And what emerges from that room is possibility, just like in quantum theory, just like in the Casimir plates, just like in your mind as you lie in the dark waiting for a dream. Maybe that's the deepest lesson the vacuum offers, that presence requires absence, that silence is not the opposite of sound, but its condition, that if we want to feel wonder, we must first feel space, space in the sky, space in the sentence, space in the soul. Because without the pause, the breath, the break, there is no rhythm, no form, no us. We think of ourselves as things, but we're also the space between things, the timing, the harmony. We are made not just of atoms, but of the vacuum that holds them. In fact, most of what makes you you is space. The atoms in your body are mostly empty. The distance between electrons and nuclei is vast, on their scale, the same way a room feels empty until you notice the light. So what does it mean to be a body, a mind, a self, if most of that self is nothing? It means you're an arrangement, a resonance, a momentary shape in the field, a fluctuation, no less real for being temporary, no less sacred for being simple, just like the universe, just like a ripple in the void. And when you sleep, what do you return to? Maybe a kind of vacuum, a soft internal stillness, a space where the self quiets and the world lets go. Dreams rise like particles, random, shimmering, strange. They flicker, they vanish, and in the morning you wake, a little changed, a little more empty in the good way, ready for the next ripple. So perhaps the vacuum is not the final answer, not the end of the line, but the question that opens everything. An eternal invitation to pause, to breathe, to notice, that the quiet between things is not absence but meaning, that nothing was never truly empty. You don't have to look through a telescope or know what quantum fluctuations are to feel the presence of emptiness. It finds you. In your kitchen, in your inbox, in your chest on long walks when the world is too quiet and your thoughts feel too loud. It's easy to think of the vacuum as something out there, a deep space thing. But the truth is, we live inside it. Not only physically, though that's also true. The space between molecules in your body is almost entirely void. Your hands, your bones, your breath. They float on scaffolding that's 99% nothing. But even deeper than that, we live alongside emptiness as a felt presence. We call it boredom, loneliness, stillness, longing, rest. We use different words, but they all point toward the same gentle vacuum we're sometimes afraid to name. Have you ever walked into a quiet room after someone has just left? The scent still lingering, the coffee mug still warm. That feeling, that hush, is a kind of vacuum, not dangerous, just real. It's absence that reminds you something was there, something mattered. And this, perhaps, is how we really meet the nature of nothing. Not as a problem to solve, but as a presence we live with. You'll find it in language. We say we need space from someone. We leave room for others to speak. We describe awkward silence as heavy and a meaningful one as comfortable. We grieve in emptiness. We heal in it. We make decisions from it when everything else has fallen away. Some cultures know this well. In Japan, there's a concept called ma, a kind of negative space that gives meaning to what surrounds it. It's the silence between sounds, the pause in a sentence, the stillness in a dance. It's not the absence of action, it's the context for it. In music, ma is what makes rhythm. In poetry, it's what gives breath to language. And in life, it's what allows us to feel. We may not call it that in the West, but we feel it all the same. It's in the pause before saying, I'm sorry. The breath between I miss you and the answer. The blank space in a photo album where someone used to be. These small human vacuums aren't tragic. They're essential. They hold weight because we've given them meaning. And yet we're taught, often unconsciously, to fear them. From childhood, we're trained to fill. Don't waste time. Don't stare into space. Don't be idle. Productivity becomes a shield. Noise becomes our comfort. We open apps when we're bored. We stream podcasts just to walk. We keep our schedules so full we forget what an open hour feels like. But there's a cost. We forget how to rest inside silence. We forget how to be without trying to become. And that's where the cultural story of emptiness gets interesting. Because while physics has shown us that the vacuum is full of possibility, our emotional worlds still wrestle with the fear of nothingness. We fear it existentially. We fear it socially. We fear it in ourselves. Have you ever stared at a blank page and felt your chest tighten? It's not the page. It's what it implies. No direction, no certainty, no safety. But here's the thing. That's where creation begins. Writers know this. Artists know this. So do dancers, designers, composers. The blank space isn't the enemy. It's the invitation. It's the place where new form can appear. In painting, negative space shapes the subject. In architecture, space gives light somewhere to fall. In theatre, the silence before a line can make the line unforgettable. It's not just that emptiness frames the moment. Sometimes it is the moment. And we forget that. In daily life, we chase meaning in achievement, activity, evidence. But the moments we remember years later aren't always the loud ones. They're the in-betweens. Watching dust dance in a sunbeam, floating in a pool with your ears underwater, that quiet feeling of being held without a word. We don't need more information. We need space to feel what we already know. And this is where the vacuum becomes not just a metaphor, but a mirror. Because real vacuums in physics don't stay empty. They fluctuate, they tremble, they birth particles out of nothing. Even the deepest nothingness is never still. And the same is true in our quiet places. Stillness doesn't mean stagnation. Rest isn't emptiness. Pauses aren't failures. They're transitions. Places where new understanding takes root. This is why, in so many cultures, emptiness isn't feared, it's honoured. Monasteries leave space in their architecture. Shrines are often simple, open to sky and wind. Meditation doesn't try to fix the mind, it makes space for it to unfold. Even grief, that most difficult kind of emptiness, has a shape. It's the vacuum left behind by love. And over time, that space doesn't close, but it changes. It becomes a part of you, like a scar that holds both pain and memory. In that way, nothing never stays nothing. It becomes the shape of what was and what could be. We also see this in how we structure our days. Think of sleep. It's the ultimate cultural vacuum. 8 hours of unconsciousness built into every day. And yet it's where our bodies heal, where memories form, where dreams stretch out into surreal geographies that help us process the real. Sleep is not nothing, it's repair. And dreaming is not nonsense, it's story, emotion, possibility, all inside the vacuum of night. So maybe we don't need to be so afraid of empty moments. Maybe the next time you feel lost or unproductive or unsure what comes next, you can think of the vacuum. Think of the space between atoms. Think of the quiet hum beneath the fields. Think of galaxies floating in the darkness between stars. Nothing is not absence, it's preparation. A kind of sacred pause before the next chapter. Like the moment just before a kiss. The silence after, I love you. The look exchange between strangers that means more than language can hold. Even in relationships, we learn the value of space. We give it. We ask for it. We create it when we're overwhelmed. Because we know, deep down, that closeness needs breathing room. That intimacy isn't about always filling, but about allowing. Letting someone unfold. Letting ourselves be without explanation. It's not detachment. It's trust. That something meaningful can rise out of quiet. That connection, like matter, sometimes flickers from places we least expect. So, yes, the vacuum lives in physics labs and deep in the cosmos, but it also lives in us. In the minutes between meetings, in the seconds between songs, in the hollow ache of endings and the soft unknown of beginnings. We try to name it. We try to frame it. We try to distract ourselves from it. But maybe the next time you feel that empty space creeping into your day, you'll pause, just for a breath, just for a beat, and you'll remember. That emptiness isn't the end of the song, it's the moment that makes it music. Let's take a walk now, not through the woods, but through the folds of reality, the kinds of paths you can only follow in thought, or in dreams. You don't need a map, just your curiosity and the ability to let go of what you're sure you know. Because tonight, we're stepping into the what if. What if space could tear? What if time could loop? What if the nothing between atoms could suddenly decide to be something else? These are not questions with answers. They're invitations, windows, cracks in the wall of certainty. Science fiction has always known this, that asking about the impossible is sometimes the only way to understand the real. So let's imagine, what if the vacuum we live in, the apparent nothing between stars, between particles, even within us, isn't stable? Physicists have a name for this: false vacuum decay. It begins with a whisper. You see, the vacuum we live in might not be the lowest possible energy state. It may only seem empty, a bowl that's not quite at the bottom of the hill. And if there exists a deeper bowl, a truer vacuum, then it's possible, even likely, that somewhere, somewhen, a patch of space has already fallen into it. When that happens, a bubble forms of deeper nothing, a more fundamental stillness, and that bubble expands, devouring everything in its path, replacing this version of physics with another. Gravity might vanish, the strong force might disappear, time might stretch, or stop. And if you're wondering how we'd know, we wouldn't. The bubble moves at the speed of light. No alarm, no flash, just one moment you're sipping tea, and the next, you've become part of something utterly unfamiliar. Gone, but also transformed, peacefully, oddly, beautifully. Now. There's no evidence that this will happen soon, or ever. In fact, the longer we go without it, the more stable our vacuum seems. but it reminds us that even the quietest realities are not permanent. They can shift, subtly, suddenly, just like lives, just like feelings, just like dreams. And speaking of dreams, what if none of this is real? Not in the conspiracy sense, not in the Matrix sense, but in the sense that what we call matter, what we call space, what we call existence, might be a kind of computation, an echo, a simulation. This is not fringe anymore. It's an idea taken seriously by a surprising number of thinkers. The simulation hypothesis says that if it's possible to simulate consciousness, and if advanced civilizations tend to run such simulations, then the number of simulated beings would vastly outnumber real ones, in which case, statistically, you're more likely to be in the imitation. It's not meant to disturb, it's meant to provoke wonder. Because what does real mean anyway? If you can feel and think and change, if you can love and lose and learn, does it matter what medium you're written in? If the vacuum is just memory space, just background code running the simulation, it's still the place where all beauty happens. Even if it's virtual, it's ours. But maybe it's not code. Maybe it's layers. Some physicists think our three-dimensional universe might be a projection, an illusion of depth cast by a two-dimensional surface we can never touch. This is the holographic principle, a mind-bending idea that suggests what we see as volume might just be a detailed mirage. And if space itself is an illusion, if what we call here and there is just information stretched across a sheet, then what is the vacuum? It's not emptiness, it's storage, it's compression, it's the place where the illusion becomes readable. But don't worry, it doesn't change how love feels, it doesn't make your pain less real, it just deepens the mystery of how such feelings can arise from such strange foundations. Let's go deeper still. Imagine this. The vacuum is not passive, it evolves, it chooses. Some have speculated that universes reproduce, that black holes, those hungry mouths of space-time, might be more than endings. They might be beginnings. Each black hole could be a tunnel to a new universe, a child cosmos with slightly tweaked physical laws. This is cosmological natural selection, an idea that suggests universes might evolve like organisms, tuning themselves through trial and collapse. And what survives are the ones good at making black holes, and stars, and matter, and life. We are not just in the universe, we are part of its lineage. Perhaps we are one successful ripple in a long ancestral chain of vacuums becoming visible. That's the beauty of what if. It doesn't have to be likely to be meaningful. You can lie in bed and imagine yourself as a child of black holes, a ripple in a conscious field, a dream drifting through a code base far beyond time. You can do that, and it still won't keep you from loving someone tomorrow, or needing rest tonight. Because that's the gift of speculative thought. It stretches you, not to escape the world, but to return to it with softer eyes. Even literature knows this. Science fiction has always played in these fields of possibility. Isaac Asimov asked what might happen if the stars died, and a computer became God. Ursula K. Le Guin imagined worlds where silence was language and darkness was not a flaw, but a feature. Octavia Butler gave us futures where empathy was power and survival meant becoming, and all through these tales the vacuum loomed, as space, as silence, as the canvas behind the stars. So if your life feels paused, or weightless, or uncertain, maybe you're not broken, maybe you're in a vacuum moment, a place where old laws are dissolving and new ones are waiting to be born. Maybe you're not empty, maybe you're pre-possibility. And here's another question. What if time isn't real? If you ask a quantum theorist and a general relativist to define time, you'll get different answers. One will say it's emergent, the other will say it's flexible. Some theories go further still, suggesting time is an illusion, a byproduct of entropy or of memory. In this view, the vacuum contains all states, past, future, present, and what we experience as now is just the slice we're moving through. Like flipping through a book page by page, convinced the story's unfolding, when it's already there, cover to cover. So what if time is just our way of organising changes within a vacuum that doesn't change? What if everything you've ever done and will do already exists? Not in fate, but in structure. You're not trapped, you're unfolding. Like a flower that already contains its bloom, and maybe, just maybe, the vacuum isn't just a physical backdrop, but a metaphysical one. The dreamer behind the dream, the listener to whom your questions are spoken in the quiet of the night. We may never know, but there's peace in not knowing, in curling up inside a story that's still being told, in letting go of certainty just long enough to fall asleep in the arms of possibility. So here we are, hovering at the edge of thought, peering over the side into the unknown. The vacuum stares back, not cold, not cruel, just vast and waiting. And maybe that's enough. Maybe in a world where nothing is truly nothing and every absence contains a future, you don't need all the answers, just a good question and a little time to wonder. You made it here, through stars and silence, through science and story. You followed the thread of nothingness, pulled it gently, and found yourself not unravelling, but remembering. So now, let's breathe. In, out, in. Let's not rush to conclusions. The universe didn't. Why should we? We began with a question. Is empty space really empty? But questions are funny things. They change as you hold them. Their shape softens. Their urgency fades. And what's left is not a need for an answer, but a deeper kind of knowing. A sense that even the things we can't explain are still worth sitting with. Still worth loving. Because in the end, what did we really discover? That the vacuum isn't empty. That nothingness is never still. That silence is a cradle where reality rocks itself into being. And that changes everything. It changes how we think of distance. Not as separation, but as structure. It changes how we think of silence. Not as absence, but as atmosphere. It changes how we think of ourselves. Not as beings carved from matter, but as ripples, rising and fading in a sea of potential. We are, each of us, soft anomalies in the void, fleeting, glorious, strange, and somehow undeniably real. For all its complexity, the vacuum carries a kind of peace. It doesn't resist, it doesn't cling, it allows, it is what it is, and from that permission comes everything. Photons, planets, pine trees, poetry, you, me, now. So what if we took a cue from it? What if we stopped trying so hard to fill every silence? What if we let the gaps remain gaps instead of treating them like errors? We spend so much time correcting the void, patching it, polishing it, filling it with noise and names and schedules. But maybe the vacuum has been trying to teach us a slower kind of wisdom, the kind that doesn't insist, the kind that pauses, the kind that listens for what might emerge. Because the truth is, you've already been practicing this. Every night when you sleep, you surrender to the unknown. You trust the darkness. You release your name. You let go of control and let the vacuum hold you. And from that, nothing. Dreams come, emotions, images, stories. And when you wake, you carry traces of those dreams into your day. A feeling, a memory, a nudge towards something more. This is how we live. On the threshold between the known and the unspeakable. We're not just people with tasks and goals. We're questions with skin, soft flashes of curiosity moving through time. And maybe that's all we ever needed to be. Not perfect, not permanent, just here, briefly, beautifully. Like a particle in a field, your life ripples outward. You touch others, you shift things, you matter. Even if it doesn't feel that way, even if your room is quiet and your heart feels heavy and your calendar is too empty or too full, you matter. because presence itself is a kind of miracle. Just being here, breathing, is improbable, and yet here you are, not in the middle of everything, but part of it, threaded into a universe that hums beneath you like an old song you somehow still remember the words to. And now that we've wandered through the physics, the paradoxes, the stories, now that we've unwrapped the vacuum and found inside it not emptiness but origin, we come back to where we started, not with certainty, but with softness. Maybe nothing is not the opposite of something. Maybe it's its mother, its mirror, its muse. Maybe nothing is what allows something to be noticed, and in that way, perhaps your quietness isn't a void. Maybe it's a gift. The pause you give someone when they're searching for the right word. The silence you offer when there's nothing to fix, only to feel. The stillness you create when you choose not to rush. These are small vacuums, little acts of cosmic empathy, and they matter. We live in a culture obsessed with the visible, the measurable, the named. But meaning often hides in the gaps, between beats, between glances, between breaths. It's there in what isn't said, in what isn't finished, in what remains open. So maybe that's the real purpose of exploring nothing. Not to explain it, but to honour it, to let it remind us how to slow down, how to let go, how to just be, not as a goal, not as a performance, but as a state of rest, like a planet drifting in the soft arms of gravity, like a mind letting thoughts settle, like dust in golden light, like a vacuum, quietly vibrating with everything it could become. You've heard a lot tonight. You've felt the invisible dance of quantum fields, the strange possibility of universe-making vacua, the gentle paradox of a space that is never truly empty. But maybe, more than any theory or story, what you felt most is the permission to be quiet, to rest, to float. We don't need to understand everything to belong to it. You already do. You always have. From the moment your atoms were stitched together by exploding stars, you have been part of this impossible miracle, born from a vacuum that wasn't nothing but everything. And so when you close your eyes tonight, when you drift into that soft internal void we call sleep, remember the vacuum is still there, humming, holding, home, not as emptiness but as space, as invitation, as the field where you begin again. So, where are you now? Still with me? Or already somewhere deeper, drifting toward that quiet space where dreams begin? Wherever you are, thank you for listening, for wondering, for taking a little time to float through nothing with me. If this brought you calm or sparked some quiet curiosity, you're always welcome here, in this small corner of stillness, where science and story slow down together. And if you'd like to return, to pause again, to breathe a little deeper, you know where to find me, just a click away in the soft dark between questions and sleep. Until then, be well, rest easy, and remember, you're not floating alone, you're part of it, the stars, the silence, the something that comes from nothing. Sleep well, fellow traveller, wherever and whenever you are. Good night.